Hello guys, welcome back to my YouTube channel. Sorry for that. Welcome back to my YouTube channel. I hope you are doing well. So guys, in this video we'll be learning about equivalent torque and equivalent bending moment in shafts, right? It's when we'll discuss about things like we're dealing with combined bending and combined twisting. We'll see these guys. Okay. We have given this typical question. Unit 3.3, equivalent torque and equivalent bending moment in shafts. And by the way, if you have not subscribed to my YouTube channel, may you kindly subscribe to my YouTube channel. And then if it is your first time watching this video, may you kindly subscribe, become the part of the family by subscribing. Uh, then you can feel free again to comment. You can feel free to like this video. All right, so we've given equivalent torque and equivalent bending moment. All right, so we have to determine the shear and the bending and the principal stresses. So in most engineer application, a shaft is subjected to torque and bending simultaneously. So you can see the stresses is induced in the shaft are due to both twisting and bending. For the design in shaft is necessary to determine the principal as well as the shear stress. All right, we are given there that a shaft can be, as you have seen, a shaft can be subjected. Let's say you have a shaft. The shaft can be subjected to bending and also can be, or to twisting, and also can be subjected to bending. Is subjected to bending and twisting simultaneously, as you have read them. So we'll be looking at those when you are simultaneously like that. So the maximum bending, the maximum bending, here bending what there, bending stress and the maximum or on the shear stress is given by the following. Okay, we know this question. We know, guys, that formula M over I is equals to shear stress over Y. Okay, when I is equals to E over R, but avoid to use this, guys. Avoid to use this part. So I like to cancel this part. I'd not say you might not use it, but me, I'm avoiding to use this part. I don't use that part. I only use this part. I don't want to lie to you guys. Most of the time I only use this part. Most of the time I'm using this. So far, since in axis level, I never use this part. I don't want to lie. Since I'm doing strength, I never used this part. I don't use that part. I'm only using this part. We just use that part. All right. Whereby we know this is our stress you've given. This is the I've talked, it's Young modulus of E of guidance of elasticity. So here, guys, there's something that they want to here it's a here they derive the deriving. There's this formula. The useful one is this one here. Firstly, okay, we have this formula there. You say this is useful expression. The principal stress is equivalent bending ME. We have that formula there. We have that formula. There you see we have that formula there, which is usefully, but we'll see. Let us not worry about that, guys, about this formula. For now I want us to focus on this one. We'll talk about that formula as we are dealing with question. You know, most guys, how I do things. I'll take you step by step. So I want us to first to deal with this formula. Says the gas formula for bending and twisting, you see, is both bending and twisting. It's a combination of bending and twisting. Then the term TE is called the equivalent twisting moment. TE is called the equivalent twisting moment. The equivalent twisting moment is given by the square root of the maximum bending moment squared plus maximum torque to it, whereby we maximum what is that maximum torque or twisting moment, then squared. This is calculated in Newton meter. This is a equivalent. Note, guys, TE, we call that TE is called equivalent. This is our equivalent twisting moment. Call this is what we're supposed to learn about, to know. Call this equivalent twisting moment. All right, this is how you calculate. Supposed to have your bending moment and your maximum torque, maximum bending moment and maximum torque. It's measured in Newton meter. As you can see, TE is measured in Newton meter. It's the equivalent twisting moment. M, it's a maximum, as you can see, maximum bending moment, that M. T, it's a maximum torque. You know our formula. It's a combination, guys. Now we're dealing with, it's a combination of the torque. It's when the shaft, I've told you, the shaft is simultaneously subjected to bending. The shaft is subjected to bending, also to what? To twisting. It's simultaneously. It's subjected to bending and twisting. This is what we'll have here maximum bending moment plus maximum torque squared, like this. This is our equation that we're supposed to know, our formula. All right, this is called this equivalent twisting moment, as you can see. All right, are we together, guys? Hopefully we are together. All those things are measured in Newton meter. So the gas formula using mil still okay. Here we have, guys, here we have the formula of equivalent twisting moment for solid and hollow shaft. You see TE again, you see, we must be very be careful there. We've seen that you see the first we have gas formula equivalent torque is this. We have this formula, do not forget about this one. We also have this now, TE again, equivalent twisting moment. Again, we have equivalent twisting moment. This is a second formula. It's equals to pi d cubed there, divided by 16, or they multiply by what? By shear stress, like that, divided by 16. Let me just do like this. Equivalent twisting moment is equals to the pi d raised to the power of 3 multiplied by shear stress divided by 16. This is for what? Solid shaft. For solid shaft, guys. Solid shaft. For solid shaft. Then TE for hollow shaft is is given by pi, right? Now you'll say, check there is 3, make no mistake. Then now will be pi, now will be d raised to the power of what? 4, not 3, minus d raised to the power of what? Of 4, like that, multiply by what? By shear stress. Divide this by 16, multiply by what? By d. This is for hollow shaft. This is for a hollow shaft, guys. This is for a hollow shaft. All right, this is for the hollow shaft, isn't it? So this is the formula to use to calculate what? Our twisting moment. Do not forget about the first one. These are our second formulas for this. Do not forget about that one, guys. We have that one again that I'm talked about it, which is square root m squared plus t squared. Do not forget about this one again. So we have these other ones. All right. So guys, let us put this into practically. Maybe you shall understand this better. Okay, you are given example 3.3 says the dimension of hollow shaft with a shear stress limit. A hollow shaft has a diameter ratio of 0.7, right? We have given the of 0.7 and must transmit 200 kilowatts at 300 rests per minute. The shear stress is is the shaft must not exceed 800 megapascal. Says now find the dimensions of the shaft. That is a question by its own. See, we have a dot there. We have the dot. This is a question by its own, separate. Then if again the shaft is now subjected to a bending moment of 4 kilonewton, determine the speed of the shaft if the power and the shear stress are to remain. You see, we have first, let us answer this one there. Find the dimensions. Talking about diameters because we're given ratio. Let us find that. That is a question. First is find the dimensions of the shaft. It's a question by its own. So I can call that, maybe I can say it's 1, right? We want to find the dimensions of the shaft. What are we given? We've given the power, we've given the speed. We want the dimensions. All right, guys, we want the dimensions. What we supposed to do with this, guys? What do you need to remember, guys? Do not forget again. All right, we have given TE, guys. By the way, we have TE. TE, guys. Do not forget that. TE, please. TE is the maximum, is the torque, isn't it? Equivalent torque in the shaft. Do you remember that we have let me just say maybe when I say the torque is simply just the torque. This thing, guys, equivalent torque or what? Equivalent twisting moment is the torque. This, guys, this is the torque is measured in Newton meter. TE, guys, the other one is measured in Newton meter. What is it? It's a torque what is measured in Newton meter. So that is equals to pi. Remember, it's a hollow shaft, isn't it? This, since we have talked about hollow shaft, isn't it, will be multiplied by d raised to the power of what? Of 4 minus d raised to the power of 4. Remember, divide by what? Make no mistake, by 16 what? D, like this, guys. All right, we want the dimensions, the diameters, guys. Where can we get now the torque for us to make the subject of formula? This. Okay, we're limited with what? With the torque. We don't know the torque there. Are we together? We don't know the torque. We don't know the Mr. Torque guy there. All right. So, but we're given power. We can find the torque. The torque again is equals to power over 2 pi n. From this formula of power, guys, power is 2 pi n t. All right. Power is equals to that. That is how we calculate the power. All right. We want the power. Isn't it? So we have that in rest per, we have our n in rest per watt. It's in 300. We have that. Rest per, remember, supposed to divide by 6 because this, okay, let's divide by 6 because this is given in rest per minutes there. All right, we have this. Now the torque here will multiply by what? By 60 will be like this. We make t the subject. If you make t the subject, you multiply by 60, you divide by this whole thing there, as I've did here. So remember, this is the equivalent torque. It's simply just the torque. We have the power. We're given the power is 200 kilowatts. This times 10 to the power 4 of 3 multiplied by 60. This divided by 2 pi. Our n there is 300, like this. Therefore, Mr. Torque there, you simply punch this on your calculator nicely so. All right. Simply punch that. If you punch that, you're supposed to get that. This torque, punch it there, will have 6.366 kilo Newton watt meter is measured in kilonewton meter. We have now this torque. All right, so since we have the torque, we know we can substitute that on our formula. Our formula there, we know that is TE, it's equals to pi d4 minus d4 multiplied by the shear stress, divide this by 16d. This is simply measured in Newton. This and this is one and the same thing. This is simply a torque, guys. Again, you can find it. It's a maximum torque. That is how you find your maximum torque. Remember this, guys. This is a maximum torque. This is how we calculate the maximum torque. We calculate the maximum torque. This is the maximum torque. This is the formula for equivalent again torque. All right. This is how we find. We know now we have a torque. This, you can substitute this here. We have 6.366 times 10 to the power 4 of 3. It's equals to pi into d raised to the power 4 minus the something they've given us. They've talked about the ratio. There's something about the ratio. They say the hollow shaft has a ratio of this 0.3. Hollow shaft has the ratio of of 0.7. All right. That is what is it has the ratio of that. This will be small, has the ratio of 0.7. All right. The hollow shaft, they said the hollow shaft is the diameter ratio. The hollow, the inside one, talking about the inner part there. Okay, small d will be what, where we see small, Remember, this if as a ratio, remember is d over d must be equals to what? To 0.7. This is simply just a ratio. This is a ratio. This is the ratio. But now let me check 0, this must be 1. They did mistake. They're supposed to say 1 is to 0.7 like that. So this will simply or they're supposed to say, okay, if I check that ratio, this textbook is supposed to say 0.7 is the ratio. 0.7 is to 1, whereby this is same as d, same as small d over big D simply equals to 0.71, like this, like that, isn't it? That's the ratio. Ratio can write it like that. Actually, it's not a mistake, it's like this. It's the same as like that. Then remember, the small ratio must make 0.7 is small. You match 1 will goes for with a big D. So if you cross multiply, you'll have 0.7 D. Right, so this will be 0.7 D. So if you substitute the small d here, it simply equals to 0.7 big D like this, but all this raised to the power of what? Of 4. Right, let us not forget that. All this raised to the power of what? Of 4. Alright, multiply by our shear stress. What is our shear stress? Are we given shear stress? Shear stress. The shear stress must not exceed 80 megapascal. We have the shear stress, guys, which is 80 times 10 to the power of 6. Divide this by 16d. So I can let me just guys, just want to you do the math. You know how to do your math here. You know how to do a math, right? So guys, here I simply want, okay, let me divide by 80 both side. I want this 80 to come to this side, to the side. Then okay, I will divide let me divide this bottom here part by 16 also. Okay, I can multiply here by 16 only. Do not leave this d here and multiply by 16 there only, then divide by that 8. So we'll have 6.366 times 10 to the power of 3 multiplied by 16 like this. Divide this by 80. Multiply by 10 to the power of 6. I have this pi, divide by this pi again. Will be divided by what? By pi. This will have d raised to the power of 4 minus like that. Oh, we have here 0.7. Remember the laws of exponents. Raised to the power 4, d raised to the power 4. Those are laws of exponents. Remember, if you have a, b like this, c, this you know will be a raised to the power c, b raised to the power c. Well, we use that there. You distribute that. So this all over, we are left with d now. So this is what we have. So the aim here is to punch this side. If you punch that on your calculator nicely, so we'll have 405.285 times 10 to the power of minus 6 like that. Then this we have again. Check, guys, this is d, these are like terms, guys. It's the same as 1 here. See, 1 subtract 0.7. They must know your maths. 1 subtract is like 1 subtract 0.7 there. You understand how we took, okay, not 0.7 is not 0.7, 0, raised to the power 4. Okay, so it's like 1 subtract 0.7 raised to the power of 4, guys. You're subtracting the raised to the power of 4. And punching this is the same as, remember these terms are the same. They will have 0.7599 d raised to the power 4 divided by d. Now you know the laws of exponents. This d will cancel with the 1d here. With the 1d will be left, will cancel. We'll take 1d there. So what about this? So we'll cancel with the 1d there. If that cancels with the 1d, we'll have now this side, we still have our 500 in that. 285 times 10 to the power of minus 6. Then this will simply equals to 0.7599 d to the power of what, of 3. Remember, we took 1 there because we subtract the law of exponents. Then you divide the both sides by this. Right, then you take you're left with that. Then you take this cube root both sides. Remember, supposed to cancel that. You take the cube root both sides. Take this cube root both sides. After that, you have did that. So as you'll take the cube root both sides there, as you can see, 5.285 times 10 to the power of minus 6 divided by 0.7599. Therefore our d will be equals to what? Let me punch. This will be 0.96. Right, then you multiply. Already I've multiplied this by 1000. This is in millimeter, by the way. Yeah, my final answer, I multiply that by 1000. So then small d, how do you get the small d? Remember, is 0.7 from our ratio multiplied by that d. We have d now, so this will simply equals to what now? D will simply equals to what? D will simply equals to 0.781.096. Then this will be equals to what? 56.767 millimeter. This is our diameter, the inner diameter. We have this now. All right, we have that. All right, so what is the second question? Those are our dimensions. Says now determine the speed of the shaft if the power and the shear stress remain the same. Okay, remain the same, does not change. That means they want us to use this new, or what we have there, they want us to use these new dimensions that they've given us. How will you calculate your power? We're supposed to find a new torque, guys, when we're having our dimensions now, because you have the dimension. How will you do that? We have to find a new torque, guys. If they want you to calculate the new speed, find a new torque, because we've calculated our dimensions. Remember, okay, we can start by saying TE equivalent torque, guys. I've shown you this formula is equals to m squared plus t squared. Okay, here's the maximum torque. We want that. But what is this, guys? Again, remember that there is this formula again that says TE is equals to pi. I've shown you d raised to the power 4 minus d raised to the power 4 multiplies. Sorry about that. Multiply this by the shear stress, divide by, we'll still remember, 16t. So you'll take this formula here, it's the one and the same thing, substitute there. This will be what? Pi d raised to the power 4 minus d raised to the power 4 multiply by what? By the shear stress, divide this by what? By 16d. It's equals to the square root of m squared plus t squared. The aim is to calculate the torque here, that maximum torque, because the maximum torque, also remember, power again is equal to what? To 2 pi nt, the maximum torque divided by 60. We want this n there. All right, so let us find the torque now. All right. This is going to be easy. We have now pi. Our dimensions is the one that we've calculated them. You remember, which is 81,096 millimeter. I divide that by 1000 will be 0,08. Let's see, 1 raised to the power 4 minus 0,05. We've just calculated this. I wrote them in millimeters. Now I've converted this. All right, remember we have the shear stress. They say the shear stress does not change. It's 80 times 10 to the power of 6. Divide this by 16, multiply by 0,0811, like that. All right, this must be equals to what, guys? This must be equal to what? To this there. We have the square root. Do we have the maximum bending? Let us check. Are we given? Here, it says the bending moment is 4 kilonewton. Okay, we have the maximum bending moment there. Is 4 kilonewton. So this is the same as 4 times 10 to the power of what? Of 3. We square because we have the square plus t squared. All right, this is what we have. So you punch this. Now it's a matter of the maths. You punch this, guys, on the calculator. The one there, all of that nyaga, all of that on the calculator. If we punch, it's a matter of punching, or you can simply you can simply take the square root of all of these, square root both sides to cancel the square root, then you transpose that. Okay, but nevertheless, let me punch that, guys, to avoid the mistake. I'll take my calculator. Pi 0,0811 raised to the power of 4 minus 0,0568 raised to the power of 4 multiplied by 80 times 10 to the power of 6. Divide this by 16 into 0,0811. All right, so I'll simply have this in this side. I will have 6362,803. It's equal to that, to this 4 times 10 to the power of 3 squared plus t squared. To remove the square root, it's a math. You square both sides. You must know your maths. Do not forget maths, guys. That and that will cancel. So here we have 6362,83 like this squared. Here we're left with 4 times 10 to the power of what? Of 3 raised to the power of what? Of 2 plus t squared. Alright, so just take that to the other side. Just subtract 63,2,803 squared minus 4 times 10 to the power of 3 to the power of 3 there. Then we square. Remember also that the squared will be equals to t squared. So to make this simple, I take the square root both sides. So here I'll have the square root of 632,83 raised to the power of what? Of 2 minus 4 times 10 to the power of 3 raised to the power of 2 like that. It's equal to t. What is our that maximum torque there? Punch the calculator. As we get 4,5 9 5 3. Let me double check. Let me double check. I'd not do mistake. 6362,083 squared minus 4 times 10 of 3 squared. Okay, I will have this value, guys, in we'll have this to be 4948,258 Newton meter. So if you want this in kilonewtons, that if you want this in kilonewton would be 4,9 what 4 here I think I have 4. My calculator give me that 8 kilonewton meter. This is what I have. I don't know, but I punched correctly. Then since I had that, I want now the number of this. Remember, power is equals to 2 pi n t divided by 60. That means if we divide by 6, this will be rest per minute. Then I want this, I make that the subject. I'll multiply by that, then I divide by that. That means n will be 60 multiplied by power divided by 2 pi n. So I want this n now. I divide 60. What was power? Power was given 200 times 10 to the power of 3. That is our power. Divide by 2 pi. Alright. Oh, sorry guys. Ish. You see, I'm mad. I want this. This is supposed to be torque. What I'm doing there. Remember, I made this the subject. So I made this the subject here. So divide by the torque. The one we just got there. 4,948 times 10 to the power of 3. Alright, so our n will be equals to what? Let me see, 60 times 2 pi, alright, times 4,948, alright, isn't it, times 10 to the power of 3. So have guys, by the way, did I include 60 here? Okay, 60 60 I will have here 385 385,986 spin rates per minute. So this is how it is, guys. We are done. This is how cookie crumbles. So by the way, thank you for watching. Thank you for watching, guys. Thank you for watching, by the way. Thank you for watching, and continue to support me. And then, guys, if you have not subscribed, please do not forget to subscribe. Click that thumbs, click that notification button, click that button, guys, there. Then I will be keeping posting some nice content for you. If you have subscribed to my YouTube channel, do so, and then feel free to comment, and then to like the video, and then feel free to share this to your fellow classmates. All the best, guys. See you on the next coming session. Next coming session, we're still under, remember, we're still under this topic. We're still under this topic, guys. So we'll be dealing with some activity. I will do some activity there. Right, I'll do the activity when we're given I want to check if we're given a camshaft. Camshaft. So if you have subscribed, you'll get this. You'll be notified when I'm posting. You'll have some camshaft. Yeah, the structure that is like this. Yeah, camshaft is sort of like that. Then you have sort of like a shaft that is acting there. Then you'll have some camshaft there. We'll discuss about this, but we'll have sort of like camshaft doing like that. Yeah, we'll talk about this, but I have a diagram that is illustrating that depleted the camshaft. So you'll see how we go about tackling this typical question before we go to Rankine formula. Then before we go to the Rankine formula, we'll see how we go about. So thank you guys for watching.